The next thing I want to go over is the undergraduate review. Some of this is, or I expect most of it is a review, nothing new. And what you'll see is we'll see some of these definitions, and I put them in a category of undergraduate definitions. For example, we'll see first normal form, second normal form, third normal form, and at some point we'll look at the graduate version of the definition. And the difference is that the undergraduate definition you might get $20, $30 an hour. The graduate definition you get $50 or higher. So it's important to, as we proceed in this class and learn more advanced definitions, to understand the subtle differences between those definitions. And you see this graph here, and what it shows, I've kind of tweaked it. It's a sign that shows a set of street names that have different database products and even different, well, I'm not showing it here, but the point is that as you see MySQL database to Oracle, the idea is that each database has certain features in terms of what is available and what is not available. And for example, Oracle 8, 9, up to 12, there are different functionalities that have been deprecated, which means they're no longer available, and new ones are added. So when you do work in industry and you have to use databases, do not assume that what you learned previously in either this class or in a previous job is going to be applicable, because what can happen is you could say, well, why doesn't this database version have the functionality as I'd seen before? So you want to be very mindful of that it can vary from product to even version. Also, check out these two links as given there. Okay, now some of these definitions are super easy. I don't want you to think that the whole class is going to be this easy. So start off easy, so build a little confidence here. So when we talk about a database, it's a collection of files that include what's called data files, temporary files, redo log files, control files, different types of files. We'll see more of this when we talk about the database architecture after the midterm. And there's something called the database instance, and that's composed of background processes and a shared memory area, okay, and system global area in Oracle terms. Now, here's a table, and this is some of the terminology I assume you've seen before. So here we've got the headings, then the attributes name. Let's say this could be an employee table. And so we have a name, age, gender. Those are the attributes. These are the corresponding values, let's say for gender, for age, and for name. And so each row is called a tuple or record. So each row that contains data is the same as a tuple or record. The column headings is not considered a row. And then when we talk about columns, we'd say each attribute's a column. So we have 3 columns here, 1, 2, 3, 4, 5, 6 rows. Sometimes what happens when we talk about the number of rows, the term we'll use is called the cardinality. So we talk about number of rows, that's the cardinality. We'll be using the word cardinality a little bit different in a future class, but for now, it just means number of rows. When we talk about the number of columns, we sometimes use degree. So we'd say this table has a degree of 3, or we can even use the word arity, that has an arity of 3. Okay, and of course a table is also a file, is also a relation. Within a database, there's a term called a key. And you might have learned key as one or more attributes used to uniquely identify a tuple in a relation. Okay, so it's one or more attributes used to uniquely identify a tuple in a relation. Within a key, there's different types of keys. Now, if a key, let's say, for example, we have a student table, typically it will make sense. We use a social security number to identify a record in a table. Now, let's say we use 2 attributes to identify a record. And so we have both social security number and last name. So if we use 2 or more attributes, that's called a composite key. And sometimes what happens is we could actually use 3 attributes, 4 attributes. The idea of composite means it consists of 2 or more attributes. And I think of the example of aircrafts, and sometimes the body of an aircraft is made of a composite material, fiberglass and maybe something else to make it strong. And so it's made of 2 or more materials. So composite key, composite composed of 2 or more things. We also have 2 very important definitions here. One is called a super key, and one is called a candidate key. So a super key, basically it's used to identify a record like a regular key, and it can consist of 1 or more attributes to make up a super key. And think of it this way. A super key is not in reduced form. And by reduced form, for example, if we had Social Security number, that would serve as the key. If we have Social Security number and we add last name, that uniquely identifies a student, but we really don't need last name here. We get by easily with just Social Security number. So it's basically a super key is a key plus 1 or more attributes or 0 or more attributes, because in this case, Social Security number is a key, but it's also a super key. So we didn't add anything to it, so it's a super key. In this case, we added 1 more attribute, so that is a super key. In this case, it's also a composite key because it's made of more than 1 attribute. A candidate key, think of a candidate key is a key in its most reduced form. And so if we have Social Security number and last name, this is not a candidate key because Social Security number by itself would satisfy as the key. So up here, Social Security number, it's in its most reduced form, that would be a candidate key. Is this a super key? Yes, it is. Now in this case, Social Security number, last name, composite key. Is this a super key? Yes. Is it a candidate key? No, because we don't need last name. And I'll just mention that if an attribute is underlined, that means it's considered part of a key. So underline key, and underline key. So a candidate key, the definition is no proper subset of that key is a super key, or the way I think of it is, for candidate key, it's in its leanest, meanest form. It cannot be reduced anymore, so therefore it is a key. Every candidate key is a super key, but not every super key is a candidate key. So this is a candidate key, also a super key. This is a super key. This is not a candidate key. Okay. Now the next point here is called a primary key. And with a primary key, I can't do that here. Here's an example of a primary key. VIN, in terms of cars, the vehicle identification number is a key. Also, if we use the license number and state, that would be considered a key, right? So the VIN is what's etched onto glass in the motor. The license number state is part of the license plate. So the question becomes, this is a candidate key because it's most reduced form. This is a candidate key, most reduced form. The candidate key which we use by default is called the primary key. So in this case, car, the VIN in car table is the primary key. It's also the candidate key. Now, is this a super key? Yes, it is. Is license and state a candidate key? Yes, it is, even though it consists of two attributes. Is this a composite key? Yes, it is, because it's made of two or more attributes. Is this a super key? Yes, it is, because every candidate key is a super key. Now, the next definition I want to talk about is called a foreign key. And here we've got two tables, student table, social's the key, and the car table, we're using VIN as the primary key. Now, if a student owns a car, then what happens, we might put a key over here called a foreign key to refer to, that particular vehicle that they own. And this is not that good an example, and I'll explain in a second why. So if a student doesn't own a car, we might have a null value here, indicating they don't own a car. If they have one car, then we put the vehicle identification number here, which matches the number here. The difficulty is if the student has more than one car, then the problem is we can only put one of those numbers here. So that gets into a design type of issue, which we'll talk about in a bit here. So a foreign key is an attribute within one relation. So there's an attribute that matches the value or primary key of some other relation. And it doesn't have to be a different relation. All right, there's a little example you can read about there. And I want to talk some about ER modeling at this point. But I'm going to stop the video here and continue in another video.